Hello, everyone. My name is Eric Schaar, and I am a third-year biochemistry major finishing up my CaNCURE co-op in the She Lab at Brigham and Women's Hospital. So I'm going to tell you a little bit about the research I was fortunate enough to do in the She Lab, and my project there was focused on delivering tumor suppressor mRNA using lipid nanoparticles. So a brief overview here of mRNA delivery. So we're all familiar with the central dogma of biology that DNA is transcribed into mRNA, which is then translated into protein. So the delivery of mRNA has been a long-running interest for a variety of different researchers due to the ability of mRNA treatment to alter the expression profile of a given host cell. By altering the expression levels of various proteins, one can have a massive impact on the way a cell operates for a given time period. mRNA also has certain advantages over DNA as it needs to only enter the cytoplasm of the cell rather than the nucleus and therefore does not alter the host cell's genome at all. However, the big disadvantage of mRNA delivery and nucleic acid delivery in general is that they are degraded very fast once they enter the body, meaning that they require a delivery vessel of sorts. So enter the lipid nanoparticle. It is a delivery platform that is highly effective in encapsulating mRNA and delivering it to the target cell. It's typically composed of 4 different lipids. So typically you got cholesterol, a PEG lipid, a helper lipid, and an ionizable lipid. The ionizable lipid is typically cationic to help keep the negatively charged mRNA backbone encapsulated within the particle. These particles are very easy to manufacture and scale up due to their self-assembling properties, and this makes them a very appealing and versatile platform for the delivery of nucleic acids to target cells. A common example of an LNP that many of us have already been given a dose of is the COVID-19 mRNA vaccine, and I'm sure that these are going to become much more prevalent due to their effectiveness. So how can these LNPs be applied to cancer? Well, as we know, many cancers develop due to mutations in tumor suppressor genes such as p53 and p10 that render their proteins non-functional. So cells containing these non-functional proteins then divide rapidly, creating tumors. My research in the She Lab is focused on using LNPs to deliver mRNA for functional tumor suppressor proteins in order to restore their normal function and stop tumor growth. Now, the data shown here is from a previously published paper by the She Lab in Science Translational Medicine. So it's already out on the internet if anybody wants to check it out. But you can see here in this third column that the delivery of a functional P10 gene using a polymeric nanoparticle platform slowed tumor growth significantly. This effect was even more potent when combined with a common checkpoint inhibitor immunotherapy treatment shown in this last column. So this work is very promising. So my work in the She Lab is, although it's in earlier stages with no real published data yet, is building upon these studies using lipid nanoparticles rather than the polymeric platform. So through the course of my co-op, I have learned a wide variety of laboratory skills, including but surely not limited to nanoparticle synthesis methods, cell culture, flow cytometry, Western blot, and some animal handling as well. And it has truly been a valuable experience for me as I was able to apply the knowledge that I previously had in nanomedicine from my past co-op to oncology, which is an incredibly interesting field to me. So by being a part of the She Lab and the CaNCURE program, I was able to see the innovation currently in progress with respect to cancer. And this has made the future of cancer therapy seem much brighter to me, and it has reaffirmed my interest in oncology, making me want to study it further. Additionally, CaNCURE has supplemented the research I conducted with workshops with case studies, allowing me to see how oncology is brought from the bench to a patient's bedside, which as a pre-med student has been really invaluable for me. So I hope to continue my involvement in cancer research and possibly in a more clinical project in the future. We'll see how that goes, but really grateful to be a part of this co-op, and it has been a great experience for me. So to close out, I just want to give a special thanks to both my PI, Dr. Shi, and my postdoc, Dr. Yudong Song, for being fantastic mentors and having me in their lab. And I also want to thank Nita, Ann, and everybody else involved with CaNCURE for this great co-op experience. So I hope that everybody here enjoyed watching this video, and thank you for watching.